So here on the screen, you can see STM32 speed test versus Arduino speed test. And here you can see some numbers. On STM side, you can see the number is 7,15,968. And on the right side, Arduino is 1,21,346. You can see the number is close to that number, means it's not much variation is there. And this is the number of count the microcontroller can count within a given time limit within a 1 second. Okay, so 1 second, within a 1 second, Nucleo 144 can count up to 71 lakh 5 7 lakh 15,968 times, and Arduino can count up to 1 lakh 21,340. Right. So by comparing these two numbers, we can say that our Nucleo 144 board is 6 times faster than this. Okay, so how to measure this, that we will see in today's video. So first of all, I'm just showing you the hardware. So this is the Nucleo 144 board, right? We have seen this in my previous many different videos, right? Actually, we have a separate series for this microcontroller, and this is Arduino Uno, right? We all started with this microcontroller only. It's very basic controller, and this crystal frequency of this board is around 16 megahertz, right? Exactly 16 megahertz. And this Nucleo 144 board is having 96 megahertz crystal. Okay, so what I did in this video, basically I wrote same code for both the microcontroller. So let me show you that code quickly. So basically, you can see this is the code for our STM Cube IDE, right? And the code is very simple. You can see HL get tick minus start time less than 1000, right? So we will simply count the number, okay? And with counting number, we are also blinking the LED. So set reset. So initially it means writing set means LED on, without any delay LED off, and then increment the count by 1. And exactly after 1 second, we are just simply displaying this count. Okay, and same code you can see for the Arduino as well. Same code, right? Here you can see. So basically, what this code will do, code will simply start initially, then in loop you can see we have initially count 0, then it will simply start counting with LED blink, means writing high and low one by one, right, continuously for 1 second, and then it will display the same value on serial monitor, right? So basically I connected both the board with my PC, right? I loaded the code on the board, and here you can see side by side we are comparing these two. So let me first close this, also close this. Okay, now let me show you the code. Okay, and then we will simply reset it, then I will show you the actual output, right, what it is showing. So basically this is our setup. You can see both controllers are connected with the laptop, right? You can see light is enough, right? Now I'm just opening the terminal and I'm just pressing the reset. So this is reset for Nucleo 144. This is reset for Arduino, right? On the screen you can see is showing you count blink in 1 second. Okay, and count is nearly close. Okay, so simply calculate the speed. So let us say we are just taking any number 68 divided by 121,346. So it's around 5.90. So from this experiment, we can say that Nucleo 144 board is 6 times faster than the Arduino, right? And this is because the crystal oscillator, the clock frequency of Nucleo 144 board is around 96 megahertz, and clock frequency of Arduino is around 16 megahertz. So I made this video because I received many different emails regarding why to choose STM32. So STM32 is an industrial standard microcontroller, industrial grade microcontroller. Arduino is also good enough, but it's for experiment purpose. So initially we can start with the Arduino, but for more complex and industrial application, you have to go with the Nucleo 144 board. So this is for the comparison. So I made this short video. Thanks for watching.